Hello there, algebra students. This is Miss Call, continuing with a lecture of, continuing with some algebra lectures for students, part of a series of lectures being presented online. Our next topic are rational exponents, and what we want to do is understand the definition of rational exponents and how to apply them, and most importantly, how we use them and associate them with roots and radicals, which was our previous topic. So rational exponents you want to think of as just being, these are equal to fractional exponents. Okay, so that's really what we mean by a rational exponent. And one of the most important ideas that, with rational exponents that you want to wrap your mind around is that every rational exponent on an expression can be expressed as a radical. So every rational exponent can be expressed as a radical or a root. Very important. We like to go back and forth between radicals and rational exponents and then see which way would be easier to evaluate a number, simplify an expression, solve a problem, etc. So it gives us a lot of flexibility. So what we want to do is basically what we mean with a rational exponent is a rational exponent is just a fraction exponent and or a root number. Okay? Condense that down. Now let's go ahead and look at the general definition from which we can draw all the applications in simplifying, solving, etc. from. So the definition my whiteboard spelling check today is not working. So the general definition we have behind rational exponents and the general form is this. If we have some real number a put to the m over the nth power, this is the same thing as saying the nth root of that a and put to the nth power. So these are equivalent, two ways of saying the same thing from which we could evaluate and simplify expressions. Another way of writing this down is we could also say, instead of having the exponent number here applied to the a underneath the radical, we could express it as the nth root of a to the m squared. Okay. Really important idea. So very, very important. We're going to highlight this and we're going to apply this to just practicing with rewriting expressions. Okay. So some other notes here is to note, I have a little bit more room here, and what you want to note is that we are also able to have negatives involved. So if you have a negative in the exponent, such as a to the negative m over n, then this is equivalent to saying 1 over a to the m over n power. So remember your rules as far as negative exponents go. We never work with negative exponents unless we're applying power rules or simplifying those, just those exponents. what we do typically in a problem is we get rid of the negative exponent at the very beginning if there's no other rules we could apply, and work with the positive exponent. So this is the same thing as saying 1 over a to the positive n over n power, which by this rule is the same thing as 1 over a, which has the nth root of a to the n. Okay. And that is, of course, the same as 1 over the nth root of a all to the n power. So that's how we work with negative exponents. So some details in applying these properties. What we want to do is look at the context in which it's used. And you have to recognize that some problems are easier to work in rational exponent form, and some problems are easier to work in radical form. So an important note, some problems are easier to work out as rational exponents, and some as radicals. So the important thing to do is to be able to go back and forth. Okay, so let's go ahead and rewrite some of these expressions. Let's just rewrite the following. And let's go ahead and start with rationals into radical form. So what we're going to do for some examples to begin with is just kind of translate our expressions using that definition. So all we're doing is rewrite this instead. So rewrite. And then I'm going to take some sample problems from our worksheet. Sample 1, what we want to do is, let's go ahead and rewrite, let's say, 2 to the 1/3 power. Okay. Based on the a to the m over nth power, this is the same thing as, I'll write my radical, I'll put my 2 underneath here, and what I have to do is make sure I get the numbers in the right place. So this is the cube root of 2 to the 1st power. And a lot of times, the 2 is understood, the 1 is understood, so I can just write it as the cube root of 2. That's our first example. Some other examples to draw from and use. Let's say we have 9, the square root of, 9 to the, let's say 2/5 power. This is the same thing as the 5th root of 9, and we could say squared, or the 5th root of 9 squared. So either would be acceptable on a quiz or an exam. These are equivalent. I'll write that there. So some other problems, drawing from our worksheet. All right, let's say I have a negative in here. Okay, so if I go ahead and add a negative number, like a negative number in our exponent. So let's say we had 2x squared to the negative 1/2 power. How do we translate this one? So this is from our worksheet. this is the same thing as saying, we make this positive first. Okay, we say 1 over 2x squared all to the positive 1/2 power. Okay. Now some people might not make this positive first and then play around with it applying the rules in different orders, but again, I like to make sure it's done first so I don't forget that I have a negative involved and I don't apply my rules incorrectly or my definitions incorrectly. Now again, we're just rewriting. We're not trying to simplify this expression. So if I take it one step further, this is the same thing as 1 over, and here's my root index number, which is 2, and this is 2x squared all to the first power, which of course is the same thing as 1 over the square root of 2x squared, because the first power is just itself one time. Okay, good. Let's do one more example, and then we'll go the other way. Oops. One more example based on the worksheet. Let's say we have 27 xy. I'm going to kind of add a few steps onto this, and let's say this is 2/3 power. So we have a fraction here. What this is this is applied to this entire quantity, so all of this is applied to the 2/3 power. So this basically is the cube root of this entire quantity, -27 over xy, all to the second power. So I can do it this way first, or I could say this is the cube root of -27 xy quantity squared. There you go. All right, now let's go the other way. It's good exercise to move forwards, backwards, left, right, change things up. Good brain exercise. So what we want to do now is rewrite the given radical expressions into rational expressions. So now let's go ahead and rewrite the radical expressions as rational expressions. Okay. As in exponential form. As rewrite the given radical expressions in exponential form. Okay, that's a more accurate way of saying it, because they're rational exponents or fractional exponents. So we're writing it into exponential form. So we're going to go backwards. So we want to go from this sort of quantity here and write it as an expression with fractional exponents, rational exponents. So let's go ahead and look at some examples. So number one, let's start out with, I want to get a good variety here. Let's start out with, let's say, the square root of 10x. Okay? What we have to do is recognize what our index number is for the radical, which is just understood 2. It's invisible 2. And all these are placed to the first power. So this is really just going to be 10x, and all of this is to the first power over 2. And that's because all of this is to the first power, and there's an invisible 2 there. That's understood, the square root. So that's how we start. Some other good problems we could do here. Let's see if we have a cube root involved. Let's say we have a cube root of 5x squared y. Again, this is all to the first power. Now, I can see that I have an x squared here. So for now, I can write them as individual units, but what I tend to do if I'm just rewriting is keep this unit together and say all of this is to the first power. So this is equivalently 5x squared y to the 1/3 power. So I don't want to simplify. There's a little bit of a mess there. And the next setup, let's say I had the cube root of 12x seconds. Let's say I have the cube root of just like y to the 7th. This is just going to be y to the 7/3. Okay, but then when I mix them up, to give you another example of a situation like this, if I had the cube root of 8x cubed, even though I could simplify this expression out really easily, I'm not asked to evaluate, I just want to rewrite it and say this is 8x cubed to the 1/3 power. And sometimes I could simplify this easily if I needed to. Okay, but all we're doing is rewriting. So in our process, this and this are equivalent. Okay, this is the same way of writing this expression. This is the same way of writing this expression. This is the same way of writing this expression, and this is the same way as writing this expression. Okay, so the next step is to really kind of mix all our rules up here and not mix our rules up, but apply our definition to a wide variety of types of problems. And it's hard to remember all your rules, so you always have to remember that your rules of exponents are always used, and you always have to apply those in the correct way. So again, it's a good idea to review those, your multiplication, division, and power rule. And let's go ahead and apply our definition of rational exponents. And so we know how to rewrite them. And now, our next step. Okay. So let's simplify. As best we can. So here we're going to have, so here's going to be our mixed, mixed problems, back in operations. And applying our definition and rules. Okay, so number one, what basically will be asked of you on exams, quizzes, homework problems is just to simplify. So they might go into more detail, but the bottom line is we want to simplify this with what we know as best as possible. Okay, so let's go ahead and say we have a problem like 1, and we have in this case, we could solve it as it is, but a lot of times rational exponents are not as easy for students to handle. So if we rewrite this as a radical first, it might prove to be more helpful. Okay, so we're going to rewrite this as a radical first to help us. And this is the same thing as saying the square root of 9, which we recognize to be 3. Okay. Another problem in simplifying. Let's say we have 3 to the 1/2 and a case like this, to simplify, I would apply my rules of exponents first, and then rewrite it as a radical. So what's really handy about having in rational exponential form is that you could apply your rules easier, which is not as easy to see with radicals. So applying my power rule, so first what I'm going to do here is I'm going to simplify by applying my power rule, which says a base that has a power exponent placed to another exponent, so 1/2 is to the power 1/4, I multiply these two. So this becomes 3 to the 1/2 times 4, which becomes 3 squared, which in this case I don't even need to translate as a radical, and that just gives me 9. Okay, so you never really know what kind of problems you're going to end up with. So here we have 3, here we have 9, and I'm just trying to condense this into the best set of examples for you. Let's say we have one with a good fraction in it, like 8 over 125, and this is all to the negative 1/3 power. And there's a few tricks involved with this one. Now we could write it into radical form right away, but we don't have the ability to work the negative first. So what we have to do is first make this positive, and there's several tricks. So what we could do is we could say, well, this is the same thing as 1 over all of 8 of 1/25 to the 1/3 power. And then we could go ahead and apply our radicals and simplify this complex fraction we end up with, okay? Or a little trick is when we apply the reciprocal properties of negatives. So what we know is if I had something like, a little side note here, if I have 2/5 to the negative 1 power, and what the negative exponent does is switch your numerator and denominator. So this is equivalent to 5 over 2 to the positive 1. So instead of ending up with a complex fraction, which I could work out and get the same equivalent answer, what I'm going to do is take a little easier shortcut route by understanding my reciprocal properties and how this works, and saying that this is the same thing as 125 over 8 to the positive 1/3 power. Oops. My spot is right here. So this is the same thing as 125 over 8 to the positive 1/3 power. Makes it a little easier. Okay, which then becomes the cube root of this quantity over the cube root of this. And simplifying this is nice because all the numbers come out nicely. And this becomes 5 over 2. Okay, so you can verify that. Just 5 over 2 times 5 over 2 times 5 over 2 give you this. And it will. Okay, so that's a start of our problem. So looking for some more goodies here. Let's go ahead and get some more practice. I'm going to look at worksheet problem 4, number H. So I'm going to look at one of your worksheet problems here. Involves a little bit more. Add some variables into the mix. Keep the brains alive and active. Let's go ahead and do give myself a lot of room. This one, this is from the worksheet. And what we have here is So the same thing is what we want to do. We could either try to work it out with fractional exponents, and you can see it might be hard to think, oh, what's 9 to the 3/2 power? Some people are able to do the roots a lot easier. So I'm going to take this in a few steps. I'm going to first convert this into a positive exponent. Then I'm going to put it into radical form, and I'm going to simplify as much as possible. So the translation here is, with the negative exponent, I'm going to apply the same trick. I'm going to make my denominator move to the top, because that's what the -1 exponent does. I'm going to take my numerator and move it to the bottom, because that's what the -1 exponent does. And I'm going to apply all this to 3/2 power. Okay, next step is I'm going to write this in radical form. I'm going to interpret what the 3/2 power is. I'm going to say, well, this means this whole quantity, the square root of this whole quantity placed to the 3rd power, 49 over 9x to the 4th. Okay, and I'm missing my 3rd power here, which I could put inside or outside. This is also the same thing as 49 over 9x to the 4th power, with all placed to the 3rd power on the outside. I always find it easier to break a problem down, especially with numbers, make the numbers smaller before you make them larger. So you have some flexibility. You could take the root first, or you could cube these numbers, but you can imagine what it's like to cube 49, and it gives you a large number. I like to break them down if I can, which is not always possible, because if this were the number 50, I'm sort of stuck. And we'll deal with that in the next set of lectures. Okay, so this gives me the square root of 49 over the square root of 9x to the 4th, and this is to the 3rd power, and this is to the 3rd power. So if I break this problem down into numerator and solve the numerator separately from the denominator, and then put the pieces back together, that might be a little easier on the brain. We could get the following. The square root of 49 is really 7 to the 3rd now. And in the denominator, the square root of 9 is 3, and the square root of x to the 4th is x squared. So we have 3x squared to the 3rd power. Okay, and for our last step, what we have here is 7 to the 3rd power is 7 times 7 times 7 times 7, so that will give you a large number. And I can't think of that number right now. Let's see. I'll bring out my calculator, because sometimes when my brain is tired, I tend to make mistakes on remembering these. So 7 to the 3rd power is 343. And then 3 to the 3rd power is 3 times 3 times 3, so that's 27. And here we apply the power. X squared, the 3rd power, is 2x to the 2 times 3 power. That becomes x to the 6th power. There we go. And that's our final simplified answer. So I'm going to leave it at that for now. There's more involved problems, and like with anything in math, the best way to achieve your proficiency is by practicing, practicing, practicing. And you can never get enough practice, because there's all kinds of different steps. There's all kinds of different steps you could do in different orders. But as long as you're applying the rules correctly, you should always get the correct answers. So note that people might teach one step before the other step versus another teacher. But as long as you're applying the rules correctly, you should be in good shape. So it's a good exercise to maybe take a problem and to do it in different ways. Do your steps in different orders and see how that works out. Make sure that you get the same answer. So I will come back and we'll practice some more problems. For now, go ahead and practice problems very similar to this and know your definition. So this is Mrs. Call signing off for a lecture on rational exponents. Have fun. Bye.